Hello everyone, my name is Satya. Welcome to this vlog. In this vlog, I'll be talking about the DNS proxy on the residential router and the DNS functionality on the end devices. Before moving into the topic, I would like to tell the viewers that please subscribe to this channel. I have already made 3 parts of this simple network configuration setup. The home setup description, already 3 parts have been done. This is the 4th part. So in the first part we discussed about what are end hosts, what are LAN hosts, what are WAN devices, what is a residential router, how it helps in connecting us to the backbone internet. That we discussed in part 1. In part 2 we discussed about the IP configuration details for both IPv4 and IPv6 on the end devices, right? In the part 3 we discussed about the basic ping, how it works between the local area network clients and a ping from local area host to the public internet host, how it works. So in this part, which is part 4, I will discuss about the impact of DNS when we are trying to access an URL or ping to the URL. Okay, so quickly I will describe the setup details that I have at my home. So today I'll be focusing on only one local area network host, that is host 1, which is having 192.168.129.14 IP address. So other host which is having IP address 192.168.129.17 will not be used as part of this exercise. So this IP address 192.168.129.14 is got through Wi-Fi interface, and the means by which it get the IP address is through DHCP, Dynamic Host Configuration Protocol, which is a stateful address configuration protocol. Okay, so then residential router here acts as a DNS proxy. DNS is domain name system. So the DNS client is PC LAN host 1, which sends the DNS query to residential router, which is a DNS proxy. In the English terms, proxy means somebody is doing a transmission on your behalf or working on your behalf. So what it will do is a DNS query comes from the PC LAN host 1 to residential router, which is DNS proxy. It proxies the DNS request to the DNS server in the backbone router, okay, which is over IPOE or WAN link, and then it sends the response that it gets from DNS server and it proxies it to the DNS client. Okay, so this is how the DNS functionality works in the home network. But now let me show you through this with a Wireshark capture. So as you see here, the DNS query that I'm interested in is the google.com. Yeah, so this is the DNS query, which is packet number 457, right? So as you see here, the source IP address is an IPv6 address, which is represented by a link local address. So as I told in my last part, which is part 3, I told in that particular training that whenever a communication within the link happens using IPv6 address, it uses a link local IPv6 address. So that's why for sending the DNS query to the residential router, which is within the link, it uses a link local IPv6 address as it is shown here, and the source address is FA80::B314:40EE::59C::5BFA, and the destination address is the link local address of the gateway, that is your residential router. So the query is standard query A type. So there are two types of query types in DNS. One is query type A and the other one is query type quad A, right? Query type A is for IPv4 addresses. So the query the IP address resolution will be having IPv4 address if it is query type A, and query type quad A will have IPv6 address, right? So we sent both the requests, standard query A and standard query quad A. It got the response in packet number 459 that google.com can be reached through this IP address, and the IPv6 address is shown here, right, in packet number 460, which is 2A0014504000E 880F and 200E, right? So this is the DNS query, how it works. Now the actual response is provided by the end DNS server, but the DNS proxy that is installed on the middle router, which is a residential router, proxies it to the client. So I'm capturing this packet on the PC LAN host 1. Okay, so let me put a filter as ICMP v6. So as you see here, since we got for the google.com ping to google.com, we got a response as both IPv4 address and IPv6 address, but the ping application is using IPv6 address to reach to the google.com, right? So the packet number 171, 383, 384 and 424 and 425, I'll discuss it after this DNS query and ICMP v6 ping. So as you see here, the ping is sent from 2A02, which is a global address. So the global address configured on your PC LAN host 1 is used as source address and is sent to the google.com IPv6 address echo ping request, and google.com responds with echo ping reply. So whenever you are surfing the internet, usually surf with google.com or facebook.com or yahoo.com or linkedin.com, like that. So this URLs are resolved using DNS query mechanism, and the response that it gets in the form of query type A or query type quad A. Okay, if it is quad A, it is IPv6 address that it will be used to communicate, and if it is just query type A, then it will use IPv4 address. Okay, so now since we have time, what I'll do is I'll describe router advertisement. So this is the router advertisement that is being sent by the uplink residential router to all hosts on the link. So this is a multicast destination address ff02::1 is all hosts multicast address, right? So it's sent here, and as you see, if I expand it, you will see that there is a prefix information which is same as what you see for the source address in the source address field of the LAN host 1, 2A02 A03F 880C 3801. So that's what is provided here, right? Then it's also giving the M2 information as 1488, the DNS server, right? Recursive DNS server is information is provided here, FE80 22B. This is the DNS server on the residential router. Okay, then you have ICMP link layer. What is the link layer address? The Segam box, and this is the MAC address, right? So the router lifetime is in 300 seconds. So 300 seconds is equal to 5 minutes. Then flags. So as I told in my previous part 1 or part 2 video, if you check, I have told managed flag and other flag. So here the managed flag is set to 0. That means the IP address will not be configured using DHCP v6, will not be configured. the router advertisement will be used to, router advertisement prefix will be used to configure the IPv6 address, which is stateless address auto configuration. Only the other information like DNS server, all those things will be obtained using the router advertisement or DHCP v6 server, right? DNS server is provided here, but it will also be provided in the DHCP v6 information request that is sent by the LAN host. Then how it gets it, the response will have different details like router information, DNS server information, NetBIOS server information, like that. Okay, so then neighbor solicitation. Now this is sent by the residential router. As you know, the link local address source is pertain to residential router. It's asking who has FE80 B3114 40 59C 5BFA, right? So then a neighbor advertisement is telling that this IP address is at this particular link address. Then again he is asking for a global v6 address and also telling that global v6 address is at this address. It's just like similar to ARP, address resolution protocol, in IPv4. Neighbor solicitation, neighbor advertisement is part of ICMP-v6 technology in IPv6. Okay, so I will just minimize this and move it to the right side. Yeah, so as you see here, the DNS server is in the backbone internet. DNS proxy proxies the information DNS query to DNS server, and DNS server response is then proxied from residential router to the actual end host. Okay, so depending upon which stack it uses, whether it's IPv4 stack or IPv6 stack, ICMP message will be sent in using IPv4 address or IPv6 address. As you saw, the DNS response contained both IPv4 and IPv6 address. IPv4 is query type A, IPv6 is query type quad A. Okay, so this is what I wanted to discuss, friends. So please don't forget to subscribe to this channel, okay, for more informative and technical videos. Thank you. Bye.